All right, so today we're going to take a look at section 2.7. We're going to be looking at more information about rational expressions. In particular, last time we looked at simplifying rational expressions and we did multiplication and division. And we found that the process that we use for fractions works, like fractions with numbers earlier on, will work the same with and without variables. It doesn't matter whether there's variables. We still try to get pieces to cancel out, to reduce in much the same way. The same will be true today as we add and subtract. So the difference in what we're doing last time to this time is the operations. Last time it was addition and subtraction. This time we're going to do, I didn't say it right. Last time it was multiplication and division. This time it's addition and subtraction. All right, so one of the things that you might remember when we did addition and subtraction back in the first unit with just numbers is that in order to add and subtract fractions, they have to have the same size denominator, okay? And we talked about it from the size of pizza, right? If I have a piece of pizza and there's 8 slices in the pizza, so I have a 1/8 piece of pizza, it's not the same size pizza as if you took the same pizza and split it into 6 pieces, right? It's the joke that says when, the woman calls the pizza place, she says, please slice it into 6 pieces because I can't eat 8. The pizza's the pizza, right? It doesn't matter how many slices it's in. The slices are different sizes, they're different amounts. So we have to make sure if we're trying to add pieces of pizza together that we're talking about the same size of pizza. So the same is true for denominators in general. So when we're looking at denominators like this one, the denominators are not the same. Now this problem doesn't tell us to specifically add, it just tells us to find the least common denominator. So one option when we're looking for common denominators in general is to simply multiply the two denominators by one another. And unless we have factorizations involved, that's the best we can do. So our least common denominator here really is going to be the two denominators multiplied. And you don't need to multiply them out. And in fact, if you do, it's counterproductive. You will find yourself having to do more work later if you multiply these back out. Don't do that. Leave them factored. And you all said, thank you, I don't want to multiply them out anyway, right? Of course. I don't want to do any more work than we have to do. So if the denominators have nothing in common, we're simply going to multiply them by one another. I'll show you what happens when they do have some things in common as those pieces come up. And you'll see what to do for this specific direction set as we keep going.
So that's just the answer?
That's the answer. Yeah. This whole problem is just asking you to find what the denominator would be. It's not asking you to add, it's not asking you to subtract. Yes. Now, the next two do ask you to add and to subtract. But do you notice what the denominators are? The same. So if the denominators are the same, just like we did when we had just numbers, all we have to do is to make it a single denominator, like combine the denominator into 1, right? It'll match. And to do whatever the numerator says to do. So in particular, the first one is addition. So we're really doing 8 plus 6. You don't have to write that out, but that's what we're doing, right? We're merging the addition together. 8 plus 6 is just 14. And if at this point we have the ability to reduce, we would, but 14 and 5 don't have anything in common, so we are finished and we're done. So some of your problems are going to be really that fast. They are. The earlier ones are, right? They're going to get more complicated and we're going to have to do more. But some of them, when you're looking at it, you're going to feel like, is that all? And the answer might be yes. Same thing for the second one, right? Y minus 5, common denominator. So my numerator is y, and the sign between them is a minus, because it's a negative right here, right? So it's y minus 2. We just spent a whole section working on reducing fractions like this. Y minus 2 and y minus 5 have terms in common, but they don't have any factors in common. There's no reducing that I can do here. Because they don't have any factors that are in common, I'm done. How are we doing so far? So far, so good? All right. Let's make them get a little messier. Now, denominators still match, right? So everything we've set up till now doesn't change. The denominator just gets combined into a single denominator. The numerator pieces need to be operated on with subtraction here because there's a subtraction between. Now I have 9x and I have minus 3y. But this says that I'm supposed to subtract all of this, right? That means subtracting each piece. So I need to sort of distribute the negative through. So this negative will apply to x and it will apply to the 10y. So I have now a negative x and I have a positive 10y. That is one of the most common mistakes to make, is that negative not going all the way through. Just stopping on the first piece and ignoring the rest of it. Don't lose your negatives. At this point, we will combine what we have that's alike. So what do we have on top?
9x and negative x.
Okay, so the 9x and the negative x, what will those combine to be?
8x.
8x. What else do we have that's common terms on top?
Negative 3y and 10y.
Negative 3y and positive 10y. What will those become?
7y.
Yep, positive 7y. Denominator is still just 2x. And yes, I do have an x on top and bottom, but they're terms, not factors. Right? I don't have any parentheses that are separating pieces that we can identify the entire, piece to divide out. It doesn't work like that. These are terms, so I'm done.
Couldn't you reduce the 8x and 2x, or would that have to be the whole thing?
That's a really good question. If all of the factors, like all the numbers were even, we would, but the 7's not, so we won't.
Okay.
Yeah. So if instead of a 7y, we had a 6y there, we would divide every term by 2. That's a great question. Okay, next one. Still common denominators, right? Okay, so we're still going to combine the numerators just like we were before. I have a z plus 3. My denominator is z squared plus 7z plus 12. I'm not done on this problem, though. This problem is actually the exact way that some of your problems started in the last section. What might I need to do in order to finish this problem? Or at least check and see if the problem's finished at this point. Yeah, the denominator is a squared terms, right? Everything we've done up till now in this section has not had squared terms in our answer. So if I've got something that's a trinomial or a binomial or has common factors or things like that, I need to look at the ability or to see if I have the ability to cancel anything. The only way I can do that is if I factor that. So this is my numerator still. My denominator very nicely has a term that's a 1 at the beginning, so I'm going to use trial and error. Positive 12, positive 7. What are my signs?
3 and 4.
They are, what are my signs first?
Oh.
Positive and positive. You're already answering the next question. What are my numbers?
3 and 4.
3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Now, if at this point the top and the denominator don't have anything that cancels out, you're done. But this one does, right? What cancels?
Z plus 3.
The z plus 3. Oh, I hit the wrong one. Let's mark the right one. Z plus 3. Okay, what does that mean is left on top?
A 1?
A 1. Don't cancel something and turn it into a 0. It is a 1. And then the denominator, I'm left with z plus 4. Okay, all good?
Yep.
Okay. Now, the first one we've done now, number 6, that doesn't have what? Common denominators. Thank you, Emily. Their denominators do not match. But they're not altogether unalike. Like, they've got something in common. How are they in common?
They both have 3.
They both have a 3, right? Both of the denominators have a 3 in them. But we need them to be the same, and one of them has a 3a, and one of them is just plain old 3. So what we're going to do is we're going to do exactly what we did when we were trying to find common denominators with numbers. We're going to multiply by whatever's missing. So there is an a missing in the second denominator that's in the first denominator. But if I multiply by a on the bottom, I have to correspondingly multiply by a on the top. Okay? So this denominator really will match now. It is 3a. The first numerator is 7. The second numerator, I have a negative, I have a 2, and I have an a. And we multiply them all together to get negative 2a. Now there is always a chance at this point that all of those pieces, there's 3 pieces here, have something in common. Maybe they are all even, or we're all divided by 3. Maybe they all have an a in them at this point. So if any of those things happen, we would look at factoring or reducing any of those pieces, but in this problem, they don't. Not all three pieces, namely the two terms on top and the third term on bottom, have anything in common, so I'm finished. Okay, number 7 also does not have common denominators, but I can't just take a 3 or an A or whatever and just merge it together. It doesn't work quite that cleanly. What do they have in common, though?
They both have X.
They both have an X. Okay, everybody good with that? They both have the X. However, one of them has a 6 and one of them has a 7. At this point, the problem is kind of like the very first one we did where I was saying find common denominators. They have the X's in common, but they don't have a 6 and they don't have a 7. And 6 and 7 don't have anything in common either,
Then you
right?
multiply them across from each
You
other.
multiply them by one another. So the first one gets multiplied by 6, top and bottom. The second one by 7, top and bottom. What will each of those denominators now be?
42.
42x.
X.
All right, so the first denominator is 42x. The second denominator is 42x, so they're both 42x's. How about my first numerator?
Negative 30.
Negative 30. How about my second numerator?
7.
7. Am I going to have a positive or a negative?
Positive.
A positive. Okay. But on this one, at this point, I can simplify something, so I will. What is negative 30 and positive 7?
23.
And it's positive, right?
Mm-hmm.
23 on top. 23 and 42.
They don't.
Wait, why is it positive?
Sorry, it should be negative because I wasn't zoomed
wait,
out.
Yeah.
It's his fault. I'm going to blame it on Gregory. All Gregory's fault. It's okay. It's my fault I wasn't paying attention. Yeah, it's negative. It's negative. Sorry. Okay, 23 and 42. Do they have anything in common? No, 23 is actually prime. It only divides by itself in 1 anyway, but regardless, it doesn't divide by anything 42 divides by. Okay, so far so good?
Mm-hmm.
All right, we're getting close. Couple more. Number 8.
They can reduce by 4.
Okay,
Actually, by
let me change what you're saying just a little bit. You're noticing that they have a 4 in common.
yeah,
Correct.
but the denominator is 4.
Okay, so the denominators do have a 4 in common. What else do the denominators have in common?
2. The D.
A D.
Oh, D.
Yeah, they have 2 in common, but 4 is bigger, so we're going to go with the 4. And then the letter or the variable they have in common is the D. They both have a 4 and a D in them, right?
Mm-hmm.
So if you want, you can multiply 1 by 8 and 1 by 4, but that is overkill. I do not need to use 8 and 4. What could I do to keep the numbers smaller in the denominator?
Can you just multiply by 2?
Yeah. I could just multiply the second one by 2. I can take the 4D and turn it into 8D easier. Now, if you don't notice it and you happen to use the 8 and the 4, it's going to be fine. You're just going to have more reducing to do at the end. So it's going to just create yourself a little bit more work later on. That's the worst scenario here. Okay, so the denominators match 8D. The first numerator stays the same, 9D minus 1. The second numerator, I have to multiply this 2 through, and it's positive, so my signs won't change. So I have 2 times 2D to give me 4D. And then I have 2 times negative 3 to give me negative 6. Okay, is that all right? Again, if you had used the 8 and the 4, it'd be okay. Your numbers would just be bigger at this point. All of your numbers would be a larger value on the top and on the bottom. So common like terms, what can I combine?
9D, 4D, and negative 1 and negative 6.
Yep. What's 9D plus 4D?
13D.
13D. And then what is negative 1 and negative 6?
Negative 7.
Negative 7. 13D, 7, 8D. Do any of those have, is there a common factor to all of those? No, there is not. All right, 9's as hard as it's going to get. Taking a look at 9. What do you see?
There's a negative. We gotta multiply it and get -6.
Okay, we're going to have a negative that we're going to have to distribute through to the 6 when we're ready to do that. You're right. What else do you see?
It wasn't X.
The denominators do both have x,
One was +1.
but one of them has a +1. So they share a common term of x in their denominators, right? But not a common factor. And you might be asking, you keep using these words term and factor. What was the difference again? Factors are written as multiplication pieces. So if they shared a common factor, for example, it might look like this. There'd be a factor of x here and a factor of x here. They don't do that, right? Terms are separated by addition and subtraction, which is what we actually have. So this x plus 1 means the x and the 1 are individual terms. X plus 1 as a whole is the factor.
Can you just add 1 to the first fraction on both common lines?
You can't, and let me show you an example of why. Let's just use some numbers. Let's say you had 1/4 plus, let me just use something easy, 1/2. If what you were doing, and that's not a good example, maybe you'll use 1/3. You gotta be careful when you're making stuff up, because sometimes it makes it look like it's gonna work. Okay?
It's because when you multiply it by something over itself, that's essentially just multiplying it by 1, which doesn't actually change it, but adding it would change it.
Yes, and that's what I want to show. If we added a 1 here, what we would be saying is that this fraction becoming 3/4 is equivalent to the fraction, sorry, 3/4, 2/4. This would become 2/4. But 2/4 is the same thing as 1/3, which is exactly what Gabe was saying. 2/4 is not the same thing as 1/3. So it can't just add something in on top and bottom. So the property that I'm using continually is this property that says that I'm allowed to multiply by something on top and bottom. And actually, let me just use my 1/3 since I mentioned it. I'm able to do that. And we encountered this back in the first unit. But I'm able to do that because of exactly what Gabe said. When I multiply by 2/2, I'm really just multiplying by the number 1. And so I'm allowed to do that. I'm allowed to multiply by 1. It doesn't change the factor. It's called the multiplicative identity. Yeah. So this part is acceptable. Addition is not. So what are we going to have to do to get a common denominator for these two factors?
Probably multiply something.
Probably. Go back to the very first problem we did together. We didn't finish the problem in adding or subtracting anything, but look at the very first problem. What did we have to do when we had an x minus, was it 10? X minus 10 and x plus
So
10.
it's x times x plus 1.
Yeah. So if the two denominators don't have any factors in common, we just have to multiply them by one another. So it looks like this. I'm allowed to multiply this by x if I do it on top, and I'm allowed to multiply this one by x plus 1 if I do it on the top too. So I'm multiplying the first fraction. Sorry, there's a 9 in there, it's causing it to look kind of weird, but this first fraction, 7/x by x plus 1/x plus 1. My second fraction, 6/x plus 1, gets multiplied by x/x. And if I do that, the denominators match now. Both denominators are x and x plus 1. Agreed? But we have to do more work on the top than we have had to do on previous problems. I have x plus 1 and I have it multiplied by 7, so the 7 has to distribute into the x plus 1. What will that give me?
Okay, so you talk about the top.
The top part of the x plus 1 and the 7.
7x plus 7
7x plus 7.
minus 6x.
Okay, pause just a second. Is that okay for the 7x plus 7? Yeah? Okay, you can continue now. Now what?
Now you would have to take that negative and distribute it on the 6, so it would be -6 times x would be -6x.
Yeah, we have the negative, we have the 6 and the x, so we have negative 6x. Can I simplify anything?
Yes.
Can I simplify?
7x minus 6x.
Right, 7x minus 6x. That would give me just x, right? So I have x plus 7 on top now. I still have the x and the x plus 1 on bottom, and here's a really good place for me to pause and mention. It is most helpful to leave it like this. Why? Take a look over here at what would have happened if we had not thought to put it in factored form on, which one was it? This one, number 5. If on number 5, we ended the problem right here, right? That would be the equivalent of ending our problem by multiplying everything out on the denominator. It's very difficult if it's in this form, as z plus 3 over z squared plus 7z plus 12, to recognize if it's simplified or not, right? If I factor it into the denominator pieces, this one actually had the ability to be to be reduced, and I had to reduce it and so forth, and it got simpler. On this one, while it does not have the ability to be reduced, we can see at a glance right now that it's finished. There's no way to factor this. They don't have any factors that are in common because there's 3 factors, x plus 7, x, and x plus 1, and none of them match. So leaving it like this is the most reasonable way to leave it because we can see we're finished.